Okay, good morning class. So today we're looking at geometry from the workbook. We're doing similarity in this lesson. Okay, so we're on page 29, similarity of triangles. Get a bit smaller. So it says show that the following triangles are similar. So how do we prove triangles are similar at this point? We prove firstly that two angles are equal. Automatically the third angle will be 1. So the three angles in the triangle. Okay, so to prove similarity, we prove that the angles are equal. Okay. So what we say is to prove similarity, we always start off with the naming of the triangle. So we say in triangle. Sorry about this. Okay, so it's in triangle ABC and triangle DFE. So what can we say about the two triangles? You can say that angle A is equal to angle D. Angle A is equal to angle D, which is 45. Why is that 45? It is given. What else can we say? Angle B is equal to angle E, which is equal to 55. Why? Given. Could I have said angle C is equal to angle F before I've said this here? No. Okay. And then the third case, angle C is equal to angle FY. We don't have to give an amount there for the angle or the value of that angle. It's just the third angle of triangle. And that is enough for us to conclude similarity. So I say therefore triangle ABC is similar to triangle. So ABC, you see A corresponded with D, C with F, and B with E. So the order is correct. So ABC. So A with D, B with E, and F with C. Can you see that? So it's going to be D, E, F. You all understand? Okay, and what's the case? What is the reason here? Angle, angle, angle. We use the fact that the three angles are equal. Therefore, the two triangles are similar. Okay. Look at the next page. Sorry, the next question. Please let me know when I go to the next page. Okay. So for some reason or other we didn't cut out B, but C is here. So where do we start? Again, we must prove that these two triangles are similar. So where do we start? We say that in triangle RQP and triangle NLM. The order doesn't matter here, but in conclusion the order is going to matter. Why? Because we know that from here you're going to get a length question. Okay. So then the order matters to us. So what do we know? We know that angle P is equal to angle L. These dots indicate the three angles that are proven to be equal. Okay? So angle P is equal to angle L, which is equal to 44. Why? That was given to us. Then angle R is equal to angle N. Why? Given. As you can see, we've got the same marking. So therefore angle Q has to be equal to angle M. Why? Third angle in triangle. So we got three angles now. So therefore RPQ, triangle RPQ is similar to triangle. So R corresponds with N, P corresponds with L, and Q corresponds with M. Y, angle. Okay. Any confusion there? No? So we're on page 30 now, okay? Thank you. So what do you notice here, people, in this question? There's no angles that is marked equal. Not so. So, if there's no angles that's marked equal, I must now work with the sides. Okay, so just take you one step back. We were told that if triangles are similar, there are two accounts, okay? Firstly, all the angles will be equal and the sides will be in proportion. Okay, if the triangles are similar, the sides are in proportion. That is why when we have this, we can say that you got RP over NL is equal to PQ over LM is equal to RQ over MN. And this is what we call the sides are in proportion. Can you see that, people? If you look at RP which is 13 over LN which is 8 and 2 over 3. Can you see that? And then if you have PQ which is 5 over ML which is 3 and a third. And then we have RQ which is 9 over MN which is 6. So that's 3 over 2. If I work all of these out, you should also see an answer of 3 over 2 there. Okay, let's pull the calculator up here. What's wrong? What's wrong? Are you saying something? Okay, so if you go with 13 over 8 and 2 over 3, you see it's 3 over 2. Can you see that, people? And of course, slow today. Okay, if I'm going to go with 5 and 3 and a third, you'll also get over 3 and a third, so it's going to be 5 divided by, that is going to be 10 over 3, which is the same as 5 over 1 multiplied by 3 over 10. Those ones twice, which is also 3 over 2. Can you see that all of them are the same? So if two triangles are similar, the sides are in proportion and they are equiangular. So now there's two ways of proving a triangle is similar. Okay? The one way is proving that the angles are the same, and the other one is to prove that the sides are in proportion. So let's go with that fact. Show that the following triangles are similar. But what do we notice in this case? There's no known angles to us, no equal angles here. You see that, people? So how do we start? We say, yeah, so it's in triangle. So ABC and triangle EFG. Okay. So we know it looks like 65 and 130 is together. Can you see that, people? So we say, okay, let's see what's AC over FD. So that's going to give you 130 over 65. So you got 130 over 65, I think it's 2. Yep. So which other angles do you think we're going to work with? Or which other lengths? 66 over 33. So it's going to be AB over ED. So it's going to be 66 over 33, which is 2. And then of course the last one is going to be BC over FE. BC is 96 over 48, which is 2. So what do you notice? The sides are in proportion. So I state obvious. I say since AC over FD is equal to AB over ED equals BC over FE, which is equal to 2. Therefore, triangle ACB is similar to triangle. Now the order again is important. ACB. So this will be the 96 corresponds with the 48. Not so. So this triangle will be FDE. Can you see that? So I went ABC. So it's DFE. And what is the reason here? The reason is the sides are in proportion. You guys understand? So again, you see that AC is with FD, and then AB is with ED. Does it make sense, people? Alright. So what do you notice here? I don't start off by saying AC over FD is equal. What I do is I first prove that all the ratios are the same, and then I link the ratios. I state the obvious by saying since that the ratios are all the same, therefore it is similar and sides are in proportion. Okay. Yes, Michael.
So would you lose a mark for not getting the right order?
You won't lose a mark, but if there's follow-up questions, then you will get confused. Okay, so if this order wasn't right, you wouldn't have lost anything here. But if there was follow-up questions pertaining the angles, you'll get confused. Okay? Anything else? No? Alright. Let's look at B. What do we notice here? Which way are we going to go? We're going to prove equiangular, or we're going to prove that the sides are in proportion? Equiangular. So we've got the angles marked here already, not so? So I say in triangle, what would the order be? A, D, E, and triangle B, C, A. You all agree with that? So that's the one triangle, and there's the other triangle. Alright, so where do we start? We're going to prove that three angles are equal here. Where do we start? Angle C is equal to angle E1 is equal to C. Why? Can I say corresponding? Was this line parallel? No. It is given. Can you see both has the same marking on the angle then? Okay, if there was one arc and two arcs, like this is one and here's two, then it wouldn't have been given equal. Can you see that? But if both has the same marking, that means to say they are equal. Right, next. D1 is equal to B. Why? Also given. The third one. What's the third angle here? Sorry? BAC is equal to DIE. On what account? Third angle of triangle. Or we could have said, say they didn't mark this, and that wasn't marked, then we would have gone with angle A anyway. Not so. But what would your reason have been? if that was your second angle, is that not in both triangles? Is that angle A not in both triangles? So I could have said angle A is your common angle. So angle A is a common angle. No reason required there. Or you could have written angle A is the third angle in triangle. Okay. Or as she said, DAE is equal to BAC, third angle of triangle. What can I conclude now? Therefore, triangle ADE is similar to triangle. So if I go ADE is similar to triangle ABC. As you can see, A corresponds with angle A, angle D corresponds with angle B, and angle E corresponds with angle C. And what's the count here? Angle, angle. Okay, not so difficult, no? Let's go with C. We're still on the same page. The last time on this page. Another one. Second last. Okay. People triangle PDE, sorry, and triangle PQR. Now you see that when the angles are given, normally the sides are in the right order. So we know that we're going to work with PD and PQ, not so. So let's see. PD and PQ. Can you see it's already in order? DE and QR. DE and QR. Can you see that? So the order is already in order. The order of that is already in the correct order. As I said, if it's given to you like this, then it's given in the right order already. Okay, you guys understand? So what do I say? I started by saying in triangle PDE and triangle PQR. Are we going to prove that the sides are in proportion, or are we going to prove that they're equiangular? Sides are in proportion. Why? Because we have all the sides here. Okay? So let's go. We are firstly going with PD over PQ. Right, PD is what? 3 over PQ, which is 9. 12 is. Why? Because that's 3 plus 9. Okay, and that's going to give you a quarter. Alright, now we go ED over QR. So ED is going to be 2.6 over 10.4. So let's check. 2.6 over 10.4 gives you a quarter. Can I stop there? Do I stop there? No. So I say now PQ, PE over PR. And that's equal to 2 over 8, which is a quarter. So hang on. Hang on. What do we see? They're the same. So I say since PD over PQ is equal to ED over QR, which is equal to PE over PR, which is equal to a quarter. Therefore, triangle PDE is similar to triangle. So PDE, PQR. Why? Why are they similar? Sides in proportion. Sides are in proportion. Okay. Beautiful, huh? Huh? Very, Jesus. 4 marks for this, Michael. Easy marks. For those of you who get 4 out of 50 for your test, shouldn't get any more less than 4. Huh? Right, D. ACE, and BDC. BCD. The order the same? Yeah, the same. So what are we going to prove? We're going to prove that they are equiangular, or you're going to prove that the sides are in proportion? Sorry? Equiangular, because we have 2 angles already. Or we could have gone with sides in proportion. I can go with any one of the 2. Do I do both? No. There's nothing wrong with us yet. No? To do unnecessary maths. So I'm going to go with proving that they're equiangular. So where do I start? In triangle ACE and triangle BCD. People, what do you notice? I name the stuff I'm busy with. I don't start by saying that the 2 triangles are similar. Right. The 2 triangles, of course, are going to be ACE and BCE. Where do we start? Angle A is equal to angle B1. Why? Given? So I say angle B1 is equal to angle A, which is equal to 90. Given. Right. We need another one. Told you earlier on. Angle C is a common angle, yes. Angle C is common angle. One more. What angle is short from this here that we haven't mentioned yet? E1 is equal to angle E. Why? Third, angle inside. Is that enough to conclude similarity? Yes. So therefore, triangle ACE, therefore triangle ACE is similar to triangle. So ACE similar to BCD. Why? Angle, angle. Okay. Yes?
What is the 1/4 in the 90 is equal to?
Sorry?
What is the 1/4 in the 90 is not equal to?
This is the one here. You see, if this one wasn't here, then what do I have to say for this angle? I have to call it DBC. But by putting a 1 here, then that means you say it's the same as just saying angle B1. Same with that 2, then same with that 1 and 2. They just make it easier for you. Do I have to use the 1? No. Okay, yes, Michael. Yes? Which is equal to 90. I wouldn't penalize you, but it will be nice if you just say, don't be that kind of girl that, leaves everything out. Anybody else? But like I say, if you leave it 90 out, you won't lose it. Okay. Alright, so that basically brings us to the end of page 30. Okay, but you guys have done 31 and 32 now. So we'll start immediately.